today's class is Math with Joy. All right, now a lot of you must have seen a bridge. You must have passed through a bridge. Even if you've not seen a crane, you must have seen a bridge, right? Now, a bridge does not move. It's not moving. It's static. Is that correct? Now, have you ever wondered how several forces act on that bridge without moving? So today, we're going to be looking at how to combine these forces into a single force, and as well as see how to split one force into different directions. So join me in today's class as we look at coplanar forces, its composition, as well as its resolution. If you are yet to like, share, or subscribe to this channel, please do yourself that favor. All right, now, before we progress, you must have known before now that a force is simply a push or a pull. So having known that a force is a push or a pull, what is coplanar forces? That's the next question. What is coplanar forces? So simply put, these are forces whose lines of action lie in the same plane. These are forces whose line of action lie in the same plane. Okay, now let me give you an instance. If you look at forces acting on a body on a flat surface, okay, you see, imagine a body that is on a flat surface, is not acting downwards, is not, So now, how do we resolve or talk about forces acting on that body when it is on a plane? That is coplanar forces. Okay, so now, under this topic, like we said, we're going to be looking at both the composition and the resolution. So in the composition of forces, we are looking at how to combine two or more forces to obtain a resultant force. While in the resolution, we're going to be splitting one force into two or more components, usually along perpendicular directions. I hope you know what I mean, perpendicular. That is on the X and Y components. Are you getting it? Are you seeing the difference now? So in composition, we are combining forces to obtain the resultant, while in the resolution, we are splitting forces into the X and Y just to get the what? The components in both the X and Y directions. So moving forward very quickly, let's look at composition. Okay, so having known what composition is, we said we're going to be combining concurrent forces into a single force. We can either use the graphical method or the analytical method, okay? So now if two forces are acting in the same direction, let's say I have force P here, and then I have force Q here, acting in the same direction. What happens to the resultant? Of course, it will also act in the same direction. So how do we get the resultant? The resultant simply becomes P plus Q. Why? Because they are acting in the same direction. So what happens when they are acting in different directions? When they are acting in different directions, let's say we have force P acting in this direction, and then let's say we have force Q acting in this direction. So the resultant becomes P minus, so we subtract when the forces are acting in different directions, and then we add when the forces are acting in the same direction. Now, what happens if P and Q, these two forces P and Q, act at an angle called theta? You see, when we just looked at like the scenario painted here, there's no angle in view. We just have two forces P and Q. Either they are acting in the same direction or they are acting in different directions. So what happens to their resultant? We've simply seen what to do. The same direction, add to get the resultant. In different directions, subtract to get the what? The resultant. So what happens to the resultant? The resultant will either follow the direction of P or follow the direction of Q. Okay, now, if P and Q act at an angle theta, that is when we bring in the parallelogram law of forces. The parallelogram law of forces. Okay, now let's look at what happens. Now we have force P going this way, and then we have force Q going this way. So since we called it the parallelogram, so let's complete the other side or dimension. I want to use broken line. Okay, so now this remains our force P while this remains our force Q. So now this is the resultant going in the same direction with what? With P and Q, right? Okay, so this is it. Now the force between these two forces, let's have B, okay. Then let's say that here is C and then here is D, right? Okay, so you're going to know why I had to complete that side. Okay, we're going to be using it. It's very important. Okay, so now what is this angle going to be? Let's quickly talk about it. This is going to be what? Theta. And I hope you know why. Here is theta. So this is going to be theta. You know why? You know why? This is angles on what? On a straight line. So if here is 180 minus theta, automatically this angle is going to be theta. So that when you sum them up, it gives you 180. Okay. Now, back to the business. How do we find the resultant of this using the parallelogram law of vector, given that an angle theta is between the forces P and Q? So now, if that happens, look at what's going to happen. If we let's bring out one of the sides of the parallelogram so that we can easily see what we are doing clearly. So now here we have 180 minus theta. And this 180 minus theta is the angle facing the side we are looking for, which is the resultant. Is that correct? Now on this, we have an angle alpha, right? With Q on this side and then O on this side. We have B here and then we have D here. So here is our P. So now to find the resultant using this parallelogram law of vectors, before we move on, I don't want to use this 180 minus theta. It's going to look complex. So let 180, you can actually use it that way anyway, minus theta be equal to beta. Okay, I want to use just something singular. So that we'll have R is to be equal to the square root, the resultant to be square root of P squared plus Q squared minus 2PQ cos beta. You know what beta stands for, right? Good. Okay, now 180 minus theta, we all know. If you know your angles very well, we all know that 180 minus theta is not an acute angle. You know that theta is an acute angle, right? Acute angles are angles that lie between 0 and 90, right? Okay, so angles that lie between, let's say 40. If you remove 40 from 180, for instance, you have what? An obtuse angle. So just note that beta is always what? Obtuse. Right? So if beta is an obtuse angle, that means it lies between what? 90 and 180. It means it is in the second quadrant. And if you have done your sine and cosine rule very well, or even if you've not gotten to that, if you have done your trigonometry very well, you would know that according to acts, that in the second quadrant, cosine is negative, right? So if cosine is negative in the second quadrant, that means this cos beta is going to be minus cos beta, and it will affect this sine. Okay, so that means that the resultant force becomes the root of P squared plus Q squared plus 2PQ cos beta. So why is it important to understand this very well? So that you won't be wondering, why is it that we are using cosine rule? Meanwhile, the cosine rule says minus 2P cos beta. So why are we saying plus? So you've seen the reason. Okay, now having seen the resultant, the next question is, what happens to the direction? Okay, so So know that force is a vector quantity, right? So what makes it vector? Magnitude, direction. So the resultant force talks about the magnitude. So what about the direction? That was the reason why we had to complete this. So I will really need this. I think I'll have to repeat it because I will have to be looking at it. We have to look at it together. Now, having redrawn this, because I want, like I said earlier, I want us to be seeing this drawing while we do what we do. All right, we have gotten the what? The magnitude. Now it's time to find the direction. So now what happens here? Now to find the direction, look at this. I'm going to pick out this triangle OCD. I have O, I have C, and then I have D. So if you look at this triangle OCD, you will see that the angle here is alpha. This is our resultant. We have our Q here. Okay, what we have here is not Q. What we have here is actually Q and BD. So let's just leave it like that. Okay, now to find this, since we are looking for direction, what do you think we're going to have? We're going to have what? Tan, right? Okay, so now we'll have tan alpha to be equal to opposite over adjacent. Okay, so now how do we find CD? That's the next question. Now look at that triangle BCD. Let's pick it. Triangle BCD. So if we pick triangle BCD, we'll have theta here. Okay, so we have our P here. Okay, so now we have B here. And then we have D, we have C. Right? Okay. So now, since here is theta, if I want to find CD, you know that here is opposite, and then here is what? Adjacent. So if I want to find CD, since it is opposite, I will have sine theta to be equal to CD over P. So since I'm looking for CD, if I cross multiply, I have CD to be equal to P sine theta. So that's how I get my CD to be P sine theta. So coming to OD, OD is equal to OB plus BD. So I already know my OB to be what? To be Q. So the question is, what is BD? Now looking at BD, BD is the adjacent side here. So we have cos theta to be equal to BD over P. So cross multiplying, BD is equal to what? P cos theta. So now going back, I have my tan alpha to be equal to P sine theta over Q plus P sine theta. As simple as A, B, C. Okay, so even if you are forgetting the formula, if you remember how it was gotten, you will not forget it. Now let's quickly look at resolution of forces. Okay, so in resolution of forces, it's very important to pay attention to this part. In resolution of forces, we are always interested in the what? In the angle that the resultant force makes with the horizontal. Pay attention. The angle that the resultant force makes with what? The horizontal. So pay attention to that. So now on my coordinate or on my plane, this is my vertical force. So let me call this Fy. This is my horizontal force. So let me call it what? Fx. Now, if this is the resultant, so my interest is on the what? On the angle theta, which is that is cos theta. Are you getting what I'm saying? So anytime you are resolving for Fy over Fy is equal to, so if it's on the negative x-axis, everything being equal, this is theta is dividing both sides, everything being equal, this is T is dividing both sides by -1 or multiplying both sides by -1. We'll have Fx to be equal to this. Our horizontal force don't have any issue. Our issue becomes with the vertical. So what happens comes with the vertical. So what happens does the same thing that happened in the first one. So sin theta becomes of 10 Newton, 15 Newton, and 20 Newton act at a point. The 10 Newton force acts horizontally to the right. The 15 Newton force right. So this is where it is.